Good morning, everyone. Today, I wanted to go over a few examples of dealing with logarithms and the properties of logarithms. Make sure you're looking back at the list that we discussed previously so that you can see stuff from the product property, the quotient property, power property, and so on. But today, we're going to focus on using these properties to either expand or condense logarithms. So, these first two I wanted to look at, you have a single logarithm and we want to expand it into multiple logarithmic terms. Okay. Hints here would be like using sum and differences to deal with that. All right. So the first one here, make sure you see that you have a fraction involved. This is going to be one big thing as far as dealing with the property. You can start by saying, hey, separate the numerator and the denominator into two separate logarithms. What you're going to find here, though, because one's in the denominator, the subtraction using the quotient property. Now, a hint there, anytime something's in the denominator, remember you can rewrite that using a negative exponent. So this is where that subtraction comes from. That we looked at when we were dealing with exponential functions as well. So it shouldn't be a surprise that that subtraction comes into play. Now, the problem is we have some multiplication going on in our first logarithm. But we also still got exponents on each of these factors. So let's finish up by breaking apart the multiplication. Then we need to deal with all of those exponents. Power property. We have three different factors to work with. Now we have three different logarithms separated here. The two that were in the numerator are both positive. The one that was in the denominator is negative. The last thing to do is use the power property. You can bring those exponents to the coefficient of the logarithm. At this point, we would have fully expanded what we're looking to do, the logarithm, into three terms. Now, the next one here I wanted to focus on brings in the radicals. Radicals definitely something we want to be comfortable with as we deal with expanding logarithms. I'm going to slide this over a little bit. What you're going to find here, since that's square roots over the whole thing, let's deal with that first. So make sure you remember when you deal with radicals, that's just a rational exponent. So I'm going to write this as 1/2 of the log of x cubed y to the negative 4. Where that 1/2 comes from the idea of dealing with a power over a root. So we're seeing that 2 in the denominator represents the square root that we are working with. Now we can break apart the x and y factors into that sum, but just don't forget you had a 1/2 out front. So we need to do 1/2, and I'll put a bracket, log of x cubed plus log of y to the negative 4. And as we said before, the last thing we need to do here is bring out the exponents using the power rule. Just be careful to see there it was a negative 4, which means they could have put a fraction here rather than the negative exponents. So this one could have been written more along these lines. All right. Now, the thing here is that we're dealing with this idea of expanding. All right. Moving forward, though, make sure you see the nice thing about expanding is we're able to separate variables that were all grouped together into individual terms. So there is something that, other than just practicing properties, could help us in the future. Right. Right now, we're just practicing properties so that we make sure we understand them. But that separation of the variables is definitely something that would help us out. Okay. Now, the next step then is to look at some condensing. All right. Now, the key is here, we're still using the property of logarithms. So make sure you're highlighting that. But what you need to see here is now we have multiple terms that we want to write as a single logarithm. You're going to take the same property, but now we're kind of working backwards. So as you see here, we had 2 logs of x and then 3 log of x plus 1. So the first thing we can deal with is those coefficients. We can write those coefficients as exponents on the argument. Make sure with x plus 1, you keep the parentheses because that whole thing is cubed now. With that done, hey, this addition means that we can bring it to a single logarithm using multiplication. So we'll have x squared times the x plus 1 cubed. And I'm putting brackets around it because what we're seeing here is this is the entire argument of the logarithm, where that would be fully condensed. Now, previous video, I made sure to show that, like, as far as condensing, one example of where we'll need that moving forward for our class is solving equations. Okay, so make sure you review that and see how I practice using that. This next problem here has 3 logarithms. What you're going to find, though, is just make sure you understand each of these is an individual factor. So let's deal with those coefficients first. So we have log of x minus log square root of y plus log of z cubed. Now, this subtraction means that this right here will end up in the denominator, but these other two are positive. So those will be in the numerator. So from here, you could just say, hey, this is log, using the common log, of course, be careful with that, of xz cubed all over the square root of y. Now, one thing I'll make sure to point out here is that I didn't necessarily say it, but make sure you see that both of these were the common log, which allowed us to condense it in the same way. Again, all 3 of these were the common log, which allowed us to condense it to a single one as well. I feel like all these examples just kind of focus on the properties with stuff that was already a common base, but make sure you pay attention to that, especially on the condensing problems, that they're the same logarithm. If you have something like, say, log base 2 of x minus log base 3 of y, you cannot condense that because these are not the same base. So you would have to leave it as it is. All right, so keep that in mind. If you have any further questions or concerns with this, please make sure you reach out to me so that we can make sure we have everything in place and ready for the final exam that definitely have several problems from both of these perspectives, from the expanding perspective, from the condensing perspective, and as I mentioned, be prepared for equations as well.